Hello, Victor here in Hawaii, and today's project is low cost, high performance solar power system. In the background, you will see 20 megawatts of General Electric wind turbines. And even though the power is free to make the electricity, we pay 34 cents a kilowatt. Our solar power is all about money and how much it costs to make electricity or buy electricity. Right now, we can make electricity from the sun for 17 cents a kilowatt. So here's our installed 300 watt solar panel. What we want to do is power a 1 horsepower submerged deep well pump. Problem is, it takes 30 amps or 4,000 watts, 4 kilowatts of power to get that pump going. Once the pump is running, it only takes 750 watts to continue pumping. Our system consists of 3 inexpensive, deep cycle, 29 DC marine batteries. Have excellent charge and discharge characteristics. Unfortunately, they don't have good surge characteristics like the very popular but expensive lithium iron phosphate batteries. This system, these batteries are only $100 a piece. The limitations of the batteries is compensated for by this. Is using capacitors to start the 1 horsepower motor. We need 30 amps, and now we have two 20 farad capacitors for a total of 40 farads, which is more than enough to start the pump. Instantaneous power. It could unload 5 kilowatts of power in 1 second. We need about 4,000 watts to start that pump. Now, what makes this all happen is taking the 12 volts from the batteries, 3 in parallel, to a pure sine wave inverter. And this particular one is remote control. It has more than what we need to power that pump. So right now the panel is putting in 13.5 volts and the output is 122 volts pure sine wave AC. The last part of this system is a solar charge controller. This solar charge controller is very efficient in that it matches the impedance of the solar panel to the demand of the batteries. So typically we have 34 volts at like a couple amps coming in, and it converts it to 14 volts at 5 amps to charge it. It's over 90% efficient. So these components, battery, capacitor, inverter, and charge controller and panel were less than $1,000. And we could pump water during power outages, and we could save 17 cents of having to pay for electricity every time we use our pump. Thank you.